right. Thanks for having me. So I have a talk. I got some slides. Also had a script for it, but we're going to go a little bit off script today because I feel like it. I was thinking about it last night, and I said, you know what? I'm going a little off script. So if you're here, you're probably a cosmonaut. And you got to give yourself a little bit of credit because you were right. Cosmos AppChain thesis was right. It's been right for years, and now it's manifesting outside of the cosmos. Everyone's talking about rollups. Everyone is finding a way to make creating your own chain increasingly easier. We're going to talk a lot about this today. Outside of the cosmos, we call them modular blockchains. Inside the cosmos, we call them app chains. But you were right, and you should feel pretty good about it. So today we're going to talk about these modular blockchains. We're going to talk about why I believe, and I assume many of you do, that they are the best solution that we've found so far to the scalability issues that blockchains face in general. But they introduce another issue, and that issue is the need to connect between these chains, especially as it contains the crossing between different instruction sets, different virtual machines. And I'm going to tell you about why I believe that permissionless interoperability is the missing piece to making modular blockchains really, really work. So let's get into it. So at Hyperlane, we like to talk about this thing, the Interchain Highway. What is that? It's a strange term, but we like to think of how can we create a safe, easy, and fast path between this increasing number of modular chains that are populating this universe. The way we do that is by introducing permissionless interoperability and this notion of modular security. So these terms might not mean a lot today, but hopefully by the time we're done, it'll make a lot more sense. So in our world, we have these internet computers. They're very cool. Starting with Bitcoin, onwards to Ethereum, Cosmos, we have an increasing number of these internet computers. And a lot of the cool things they let us do, I would argue, is mostly due to the fact that they introduced for the first time scarcity into the digital domain. And this introduction of scarcity gives us everything from sovereign money and permissionless access to computation. But with this comes a big issue. As we introduce scarcity, we're now competing for scarce resources in a way. So I really love this visualization. I don't know if any of you have seen it before, but it's one of my favorites. We got Bitcoin and Ethereum blocks visualized as buses, and transactions of different sizes visualized as these little South Parky looking characters. I think this does a great job of illustrating what digital scarcity really means for us. You want to get on the bus. Well, there's only so many seats. There's a certain block size. In the case of the bus, there might not be enough seats for you, and you have to catch the next one. In the case of blocks, there's surge pricing. And what does surge pricing mean? So like, why are you here today? You're here because you care about crypto, you care about blockchains. And all of us are working to increase the demand for these blockchains. But we just talked about digital scarcity. So if we do that, what's that going to actually mean? We're going to compete for them, and we're going to run into these issues. Everyone here has probably at some point felt that the gas was too damn high. So modular blockchains and the app chain thesis as it's being materialized today are what I think are perhaps the best solution for the issues that are caused as a function of this digital scarcity. And so enter Hyperlane. We're going to cover it in more depth today, but for now, all you need to know, Hyperlane is a permissionless interoperability layer. And the only important thing to take away from it is it's a tool that we're building to let anyone connect any chain. And any chain is the really important part here. We want to allow you to be able to cross between different VMs, between different instruction sets fairly easily. You should be able to connect EVM chains with different Cosmos app chains, with Solana-like chains. Right now, we're seeing people creating SVM, sea-level-based rollups. Fuel is going to be released sometime in the next few months, and that introduces another instruction set. So Hyperlane is how we hope to allow anyone to do that. And we're coming to Cosmos. So in the next couple of months, Hyperlane will be implemented as a Cosmos SDK module, thanks to the amazing work of the Strangelove team. And it'll be implemented as a Cosmos implementation, thanks to the great work of the Mitosis team. If you happened to be at Modular Summit the other day, you may have caught Sunny from Osmosis talking about their interest in using Hyperlane to connect with rollups. So coming to the Cosmos soon. So I mentioned to you that I think that permissionless interoperability is required to make sense of the modular stack. I think of it as the final layer in the stack, the one that completes it. Because if now we are seeing more and more tools like the OP stack, like Celestia, then rollup service providers such as Caldera and Eclipse and AltLayer, all of them are making it increasingly easier to create your own rollup, your own app chain. And as you do so, you need a way to connect them. And what we're seeing also is a proliferation of these different instruction sets between these different forms of chains. And so having an ability to connect them without depending on anyone else, being able to do it in a completely sovereign way and putting your own destiny into your hands is imperative. And that's where Hyperlane comes in. But why isn't this the case today? Why is it that outside of IBC, pretty much every form of interoperability, especially ones that pertain to generalized message passing, they're all permissioned? You always have to ask someone to add you, to support your chain, to support your environment. Why is that? I would argue that it's primarily because of the fact that interoperability today, especially in the form of generalized message passing, takes the form of tightly coupling the messaging interface on one hand, right? This is the product. This is what you're coming for when you're using such an interoperability protocol. And it tightly couples it with the security model. It doesn't have to be this way. It's not written anywhere that this is the way that it has to be, but for some reason, it just is. So with Hyperlane, we believe that modular chains deserve modular security. Seems like an abstract concept. Let me try and make it a little bit more vivid. Everyone here probably has a bank account. I have one too. Maybe I shouldn't, but I do. And when I try to withdraw a small sum, say $50 from my bank account, I just need a PIN. I can use the machine. I don't have to do any special processes for it. The security protocol for such a small transaction, enter your PIN, take out your money. But say I try to do a much more meaningful transaction. I try to wire $50,000 out. Now I get ran through a different security protocol. The bank now wants to see my identification. They want to ask my name. They want to ask who else is on the account. Do I recognize any of the past 10 transactions? Is there a recurring direct deposit on my account? They run me through a series of questions. And if you ever tried to close your bank account and withdraw all the money in the same day, they ran you through an interrogation, and you probably have a certain feeling right now as you're hearing this, because you know how difficult it is to close a bank account in the Western world nowadays. So what's the bank doing? Different security for different context of your user action. But we don't do this in crypto. We certainly don't do this when it comes to traversing between different chains. Whether you're moving $100 or $100 million, we treat you exactly the same. But when's the last time you saw a 9-figure transaction that wasn't an exploit, that wasn't a bona fide hack, right? Rarely happens. So what is revealed then, that once you introduce this ability, a lot of people are starting to think, you know what, this is sensible. Maybe we should have different security protocols for different actions. And this is something that Hyperlane brings to the fore. Normally, and remember I said we're going to go a little bit off script, tend to go over different forms of interoperability, different flavors. But everyone here, if you're in Cosmos, you're probably very familiar with it. So we'll do this really quickly. So you have native verification. Basically, I'm just trusting both chains that I'm traversing between, and I don't introduce anything in the middle. If we could do this everywhere, we would. We can do this everywhere where we have Tendermint chains. We can do this beautifully with IBC. But you want to do it in other instruction sets. You want to do this in the EVM. It becomes very costly. And obviously, this is changing by the day through the amazing work of folks like Polymer and other teams. But today, this is still quite costly. It's quite difficult to do. So oftentimes we have to resort to external verification. Same concept, still trusting the two chains connected, but now we have to add something in the middle. And that's our external verification. So where does this come into modular blockchains, right? We just talked about how there's going to be an increasing number of them. There's many great people that are working towards increasing the ease by which we can create our own modular blockchain. And so if all this resorts in now that I can create my own modular blockchain in less than 10 minutes, how are we going to deal with this if I only have a permission form of interoperability? Hence, modular blockchains absolutely need permissionless interoperability. Right? You can see a world where they keep proliferating, and as the number of app chains, as the number of app-specific rollups and generalized rollups continues to increase, we absolutely need a way for the users of those chains and the creators of those chains to connect with anyone at will on their rules. So these sovereign rollups need sovereign interoperability. So Hyperlane lets you do that. And on this little schematic here, we see the full life cycle of a Hyperlane message. Only a couple things to really pay attention to. Our mailbox. Simple program, sends and receives messages. It does exactly what it sounds like, because it's a mailbox. Then we have a relayer, a permissionless role. Anyone can relay the transactions that flow between any mailbox. You could relay your own. An app can choose to relay their own. A specific chain team or rollup could choose to relay their own transactions. And lastly, the most important part, our interchain security modules, right, where this notion of modular security comes to the fore. So let's run through a transaction with Hyperlane. You send something to the mailbox. In that message that you send, you specify the destination. Where is it going to? Both the chain and the contract. There might be several of them. And then you send some arbitrary bytes. It's going to be call data to initiate a function call on the destination. Maybe you want to initiate a swap. Maybe you want to borrow something, withdraw something. Maybe a mixture of those actions. This could be an asset transfer, or it could be as simple. I wouldn't recommend this, but you could just send a message to ask me how I'm doing. But I'm happy to tell you off-chain. Then, depending on the security configuration, we might have some type of observer, some type of either a staking validator, either a watchtower in an optimistic transaction. They're looking at the mailbox, and then once some conditions are achieved, they attach a digital signature to that message, attesting to what the validity of what they just saw. On the other chain, we have our security module. Think of this as logic through which some conditions that you set, like what we just talked about with the bank doing when I'm trying to make my large wire transfer. So a certain transaction size might route to a different security model. A certain type of action, perhaps an upgrading action, can go through a different security module. And then we have a relayer. The relayer is always looking at the mailbox. It sees your message. If it sees some signatures there, it's all right, great. I'm ready to send it home. And then the relayer initiates the process function on that destination mailbox. We're not done yet. That means that that transaction was included in a block on the second chain, but it still needs to pass the tests of the interchain security module. And if it does, only if it does it proceed to its destination, that final contract, the other side of your app. What happens if it failed? What if it failed the test? Well, it's still included in that block, but it never arrives at the destination. You're never impacted by that. So what does this let you do? Modular security can take many different forms. You could have economic security, where people are staking assets. They could stake any asset with Hyperlane's variant of modular security. If you're an app chain, you could leverage your existing validators and staking of your main asset to provide economic security for messages that are being sent. But what if, say, you only have $10 million of economic security and I'm trying to do a transaction for 20? That's not enough. What do we do then? So then we could route it through a different module. For those cases, we could route it through an optimistic module. In the optimistic case, we wait a certain amount of time. We wait an amount of time that you, as the implementer, configure. Maybe you want to wait 5 hours. Maybe you want to wait 12. Maybe you want to wait 24 or 7. It's really up to you. During that time, you and anyone else can observe that transaction, and you can ascertain, like, is this something that we should be letting through? Is this something that should arrive at my destination chain? Lastly, you could even do something as simplistic as a multisig. Maybe you just want to get started. You just want to test it out. You have a group of people that you feel are trustworthy. Maybe it's reputable businesses. Maybe it's your own team. So you can have a security module that is just a multisig-based validator scheme. So that's available as well. But the cool thing about this, not just that you can route based on the context of what users are doing, you can continuously update your security settings. Changing a security module is as simple as pointing to a new address. So today we already have external teams that are working on their own security modules. In fact, a ZK-based module is coming to Hyperlane sometime in the next couple of months, built by a totally independent team. So with Hyperlane, we envision, ultimately, a market of different security modules. And that type of open marketplace is something we think will help spur a lot of innovation and allow people to stay at this, to always be at the state of the art when it comes to security. You'll never feel as if security has passed you by, because you can always change to the latest and greatest. One way to make this more particularly vivid is through an example that runs through bridging, something that probably everyone here has experienced at one point or another. Traditionally, bridging is done through what I'd call an omnibus bridge, where all the assets from all the people go into the same place, into this nice little contract that almost ends up looking like a cute honeypot. Everything is secured in the same way, and if there's one breach in that security model, all the assets from all the people are now at risk. But in the form of modular bridging, you can utilize what in Hyperlane we've called warp routes. A warp route is individualized for an asset or group of assets, and each can have configurable security. So you can have a warp route going, say, from Ethereum into your app chain, and you can have a single warp route for USDC, but a different warp route for USDT. And then you can have different settings such that when we have a $50 million USDC transaction, let's treat it in one way. But when we have a $5,000 USDC transaction, let's treat it in another. So what else can you do with Hyperlane? You could have interchain swaps, swapping without a need for bridging by utilizing liquidity pools on both sides. You could have interchain accounts. The really cool concept of interchain accounts introduced in Cosmos is something that Hyperlane has extended beyond the Cosmos into different instruction sets. You could utilize interchain oracles. In fact, just this past week, an external contributor created a tool really to allow anyone to bring Hyperlane chainlink feeds via Hyperlane to any new chain permissionlessly. And lastly, my favorite use case is interchain margin, but we went off script too much, so we ran out of time. I can't talk about it today. What's the end game for Hyperlane? Looks like inner roll-up networking. It looks like more competitive relayer services, that security module marketplace that I've talked about. And of course, it wouldn't be a crypto conference in 2023 if we didn't talk about intents. It's obviously interchain intents. So if you have any questions, you can go to our docs. You can join our Discord at /Hyperlane. You could follow us on Twitter. Or you could reach out our teams here. We're going to be here for the next couple of days. You can always hit me up by email or on Telegram. We'd love to talk to you. Thank you very much.